Hello, it's Keith here, and this is the third in the SuckHunt series of my Z80 programming tutorials. Nearly forgot the processor I'm working on today. SuckHunt is my Operation Wolf Duck Hunt parody game. Here you can see it starting up here. It's a stereoscopic rail shooter, and it's available for download now. You can get it for free and you can have some fun with it, hopefully, or maybe you can't if you don't like it. But anyway, as I say, basically it's a little game that I created as a bit of fun, and we're going to be looking over some of the code today. And today we're going to be looking at the code that handles the gun. Now, at the moment, I've got the 666 shooter, as it's called, but if I shoot that minigun, chibi gun weapon there, I can select that. Now each gun has different firing attributes. The chibi gun you can hold down fire and fire in a long sequence. Some of the guns have different fire power and different shot spreads and things. So there's 4 guns in total. You can see at the bottom of the screen on the left, you've got the name of the gun. In the middle, you've got a sprite representing the gun, and then you've got the number of bullets. Now we can reload the gun if we press space. If I just turn off the 3D effect here, you can see it clearer. So if I fire and the bullets go down to 0, I can press space and reload, and if I reload when the gun's full, I can switch. We can also reload by shooting the heads-up display in case you've not got 2 fire buttons. So we've got a couple of options there, and we've also got the collision detection, where if I shoot and I shoot the bats or the power-ups, they will get hurt and eventually disappear. So we're going to be looking over the code that handles that kind of thing today. The idea of this series is, if you're creating your own games and you don't know where to start, you have no idea what kind of things might work and might not, well, I'm not claiming to be any kind of genius, and I'm not trying to say that I've done things the right way, but they do work. The things I've done, at least, create a functional game, so maybe you can get some advice from them. And as I always say, and as it says up there, you can get the source code from my website, so go ahead and download it. And as I always say, you can make any kind of use of it you want. You can rename the game and put your own sprites in it, and if you manage to sell it and make millions of pounds, great, good luck to you. I don't care. That's what I'm creating these games for people to benefit from them and learn things and make their own fun stuff. So use it in any way you can. So we're going to go over some of these gun routines today. So the first one we've got here is the routine that shows the gun, the name of the gun. Now the important thing to understand with the drawing routines for even the text is everything is using XOR, which means if we draw to the screen and there's something already there, it will invert what's there. That means if we draw the same thing twice, it will remove it the second time. The other thing is all of the routines are stereoscopic 3D. So 2 layers are drawn. One is the red layer and one's the cyan layer, and that creates the 3D effect. This is relevant when it comes to drawing something like the text here. We're drawing the text with a 3D coordinate, and a Z, which is the depth, and an X and a Y. And so that's all going to come up here. So we're showing the gun name. The name is split into 2 parts because the gun names are a bit long, so there's 2 lines. So we are selecting the X and Y position for the first line of the gun name here. We're then getting the attributes of the currently selected gun. Now these are in the ROM definitions. These are fixed definitions. If I just find them somewhere here, where are they? Here they are. So these are the gun attributes here. So you've got the name of the gun, the amount of bullets in a magazine, and the amount of bullets whenever you collect a new iteration of the gun, because that will give you more ammo to reload. So you can see they've got various attributes here, and the function we just saw, this get gun, will get the attributes of the currently selected gun. And what we want here is the address of the text that describes the gun. We then move that into HL and run our print string to show the first line. We then move to the new position for the second line and run print string again to show the second line. The 2 lines are consecutive within memory of the text which defines that gun. Now that's showing the gun name, and we use this get gun function to select that. We are basically getting the offset for the gun configurations, the gun number. There are 8 bytes for each defined gun. We're calculating the offset and returning the offset to those gun attributes in IX, and you can see that being used just there. We're using IX because we often use IY for the object, which is the enemy we want to actually deal with, because we'll need to compare the attributes of the gun and then decide how we're going to deal with the enemy accordingly. Now that's the fixed attributes of the gun which are in ROM, on the ROM systems, but we also have some attributes of the gun in RAM, and this is the amount of ammunition. The amount of ammunition loaded into the gun. For example, the 666 shooter can only have up to 6 bullets in the gun, but it has infinite ammo. so it's got infinite ammo but only 6 that can be loaded, whereas the minigun, I think it can take 100 ammo in the gun but up to 255, which is the theoretical limit of the ammo you can hold. So that's why we've got these two attributes, and we're loading those. Again, we're loading the offset to the ammo data, 2 bytes for each, the amount in the gun and the amount held in total, and we're calculating the offset there. Now, here is the reload routine. This is when the player tries to reload. Now, as I say, all of the graphics routines are XOR, so you'll often see things being drawn to the screen to remove them, and that's what's happening here. We're showing the bullets to the screen, but we don't want to show the bullets. We want to take away the old bullets from the screen. So that's what we've done there. We then get the attributes of the player's currently selected ammo here, and we get the current number of loaded bullets here. We then get the amount of bullets that can be loaded into the gun from the gun here. This is a fixed value, and we compare them. Now, if the gun is already full, if we try to reload a full gun, we switch to the next gun, and this is so we can use the same button for reload as for switch weapon. So if we are already full, we swap to that gun. If we're not full, we load the amount of bullets it will take to fill the gun. We're into D here because we might have 5 bullets in the gun, but the gun can only take 6 bullets, so we would only want to add 1 bullet in that case. Okay, so that's checking if the gun's already full. Then what we're checking is if there are any bullets left that we can load. If we've already run out of bullets, then we are going to switch to the next gun, and that's what we're doing here. If we've got no bullets left, even if the gun isn't full, we need to switch to the next gun. If we get to here, we're actually going to decide how many bullets we want to load though. So what we've got here is the amount of bullets that the gun can take, and then we are going to see if the amount of bullets the gun can take is more than the amount of bullets the gun needs to fill it up. And if it is, then we're going to use the amount that the gun needs to fill it up, and if it's not, then we're going to completely refill the gun, which will be the more common case, I think. So that's what we're doing here. We're then subtracting the bullets we're going to put into the gun from the amount the player still holds, and we're going to update the amount the player still holds here accordingly. We then update the gun with the new total of the bullets here, and then we are doing a bit of a special one here. We're updating the amount of available bullets in gun 1, in the first gun, which is the 6.66 shooter, which is the default gun and has infinite ammunition. And the way we do that, we just keep adding 255 as the total amount of bullets remaining on that gun. A bit of a cheat, but that's what we do. We're then using this sound effect routine, play sound sequence, and we're just defining the sound and the priority of the sound. If the priority is lower, then it won't play. So that's playing the reload sound. And then we're running the show bullets routine again. The first time here was to hide the old one, and the new one is to show the new remaining bullets. So that will down the total bullets held, and it will update the amount of bullets in the gun accordingly. Here's the swap gun routine. As I say, again, we've got the routine to show the gun name at the start, which actually takes the old name off. We'll see down at the bottom a new one to show the new gun. And what we're doing here again is we're loading the address of the sprite of the gun, and that's the icon showing the currently used gun. We are then using a special routine on the master system only. Now the master system's a bit odd. I'm using the timeout to do all the graphics, and I can't do XOR on that system. So we've actually got a modification on that. Basically the game was written originally on the CPC, then it was ported to the Next and the Sam Coupe, and then the systems that were a bit tricky, the MSX2, and then finally the master system, which basically there are kind of tricks in those later systems to make it work like the earlier ones, and so the master system can't do XOR. So what I have is a function called setRemoveSprite, which modifies the sprite routines to blank out the area that's being drawn to, and I have a setDrawSprite, I think it's called. Where is it? There it is, and that will draw the sprite properly, and that alters the sprite drawing routines so that they have the same effect as if the system was using XOR. So that is setting so that on the master system this routine will remove the sprite from the screen, whereas the other systems, because it's XOR, it would remove it normally. I know that's a pain, but it's just a case of you've got to make the code work on all the systems in the simplest way you can get away with it, and that's what I did. So that's removing the sprite from the screen, and then what we're going to do is we're going to switch to the next gun. Now there's 4 guns in total, so we are masking the bottom 2 bits to go from 0 to 3. And what we do is we select the gun number, and then we check the ammunition of the gun, and if we've got no bullets for that gun, then we aren't going to select it, because by default the player only starts with one gun and they have to collect other guns later on, and if they use up all the ammo in that gun, then the gun effectively disappears from their held weapons. So that's what we're doing there. We're just going to keep switching guns until we find one that has ammo. The first gun has 255 ammo at all times, so we can always select that. So we've now got the valid gun. Now each gun has a different cursor. The cursor that the player moves around to shoot, it's different depending on the gun. So we need to select that. Now the sprites are 16 bytes each. All of the sprites are full color, even on the 16 color systems. So there are 16 bytes for the 8x8 sprite. But on the MSX2, the code works differently, and it's a pixel offset in VRAM. So again, we've got a bit of a quirk there in the way that this is working. But we're effectively here converting the gun number into a cursor sprite offset, and we are setting the cursor sprite offset just here. And then we're running the show cursor routine a second time to show the new cursor to the screen. What we're doing next is we are adding the offset within the sprite definitions to the gun number. There's 4 guns in total and each one has a separate sprite. We're updating the sprite for the gun, and then we're showing the new sprite for the gun icon in the heads-up display at the bottom of the screen. We're then drawing that to the screen, showing the new gun name, showing the new gun bullets, and we're making the sound of the gun being swapped. Okay, so now we're at the code that's going to handle firing the gun. So what we're going to do here is first we're going to check the position that has been shot. The pos X and pos Y are the position of the cursor as it's currently is the case. There's the old cursor, which is where it was last drawn, and there's new pos, which is where it's currently drawn. So if the player's fired, we're checking the position, and if they've shot at the bottom of the screen, they've shot the heads-up display. And for the light gun and for mouse systems where you've not got 2 mouse buttons possibly, shooting the heads-up display will reload or switch the weapon. And so we're checking that here, and we're jumping to the reload if they've shot the heads-up display. What we're doing next is we're checking the amount of bullets the player has left, and if they've got no bullets, well, they aren't going to be able to shoot, are they? So we're going to bail out in that case. We've got a second check of the heads-up display position here. There's actually 2 there. There's 2 versions of this code. One is for the minigun, and that's where you hold down fire, and the other is for the other weapons where you just repeatedly click fire. So there's 2 versions there. Now what we're doing here is we are converting the coordinates of the cursor as it's held in new pos X and Y into logical screen units. Now the cursor works at whatever is appropriate for the screen, so that could be bytes or pixels, it could be something else, but we need to convert that to logical units, and the logical units are measured in pairs of pixels. The reason for that being that our screen might be 320 pixels wide, but we want to work in a value that goes below 255 for convenience on these 8-bit systems. So we're shifting those to convert the coordinates accordingly so that the coordinates of the cursor now match the coordinates of what we want to test compared to the enemy's position, which is in logical units. We're then going to update the bullets on screen. We show the bullets again, XORing it, so effectively removing them, decrease the bullets and show the new amount of bullets. That's what we're doing there. And what we're doing next is we're going to test each one of the enemies and see if any of them have been shot. So we're getting the pointer to the object on screen, the count of the object, and we're going to test each one. And we test 2 things. We test bit 7, which is the status of the object, whether it's living or dead. If the object is dead, we don't want to see if the players shot it because we really don't care. And we then test bit 6, which is the state of the object, whether it's an object that can be shot by the player or whether it's a piece of background or something. So we're testing both of those. If the object can be shot, we're running test sprite IY here, and that will handle how the object is affected by being shot, and we'll deal with that. And after that loop, we're then just making the shot sound very low priority because the minigun is firing all the time, so we're only going to play that if no other sounds are playing. Okay, so this is the code that's handling the player having shot at an object that could potentially be shot. We're using the range test function to see if the position of the IY object and the position of the player's shot position, the cursor, with the range of the gun, has actually hit that object. And the way this works is the carry flag will be set if the object has been hit. So if there's no carry flag, then we haven't hit the object and we've nothing left to do. If we've hit the object, we make the hit sound, and then what we're going to do next will depend on the program, the bottom 6 bits of the program, which define the kind of object it is. Now, there's a different kind for each of the enemies. There's 2 kinds of bat. There's the regular bat, there's the gobby bat, there's the Chibico character, and there's the Corona character. And each of these, well, actually, but basically at this stage, they're all just an enemy. So they all get treated the same for being hit, but they have different movement codes and different other attributes. So if it's an enemy, we're going to use this hit enemy function. If we've shot a power-up, we're going to use the hit gun function, which is slightly misleadingly named. There are 5 kinds of power-up. There's 4 guns and there's 1 health power-up, but it's actually handled by the hit gun routine, so possibly a bit misleading. Anyway, the hit enemy routine will load the gun's attributes. It will subtract the power of the gun from the life of the current enemy, and if the life has gone below 0 or equals 0, the enemy has died. And when the enemy dies, we give the player some score because they've done well. We make the enemy dead sound, and we remove the sprite from the screen. We're first setting that removal routine for the Master System, removing the sprite from the screen. And then we're running the off-screen routine. This is also handling the movement of objects if they are moving across the screen when they've gone off the screen. So that will refresh the object so that it will respawn at a later date. If the player's shot a gun, then or power-up, first we need to remove the sprite from the screen. We're setting that remove routine on the Master System, removing the sprite with the XOR routine, and then setting back to normal mode on the Master System. We are then setting the timeout of the object. This is the life of the object. Now, a dead object, the life will define it as actually respawning at a later date. So that's what we're doing there. We're then checking the sprite number here. We are masking for the sprite number and subtracting the gun sprite. The gun sprite is an offset within the defined sprites of the first gun, and so this will basically give us a value from 0 to 3 for one of the guns, or a value of 4 for the health power-up. And so that's what we're doing here, and we're jumping to the health power-up routine if the player has shot a health power-up. If we get here, though, they've shot a gun. So we're removing the bullets and the gun name from the screen. We're removing the sprite from the gun. We're then switching to that gun with this routine here. We're then updating the bullets here. We're then removing the number of bullets from the screen because we're going to add some bullets to the current magazine. We get the gun attributes here. We get the amount of bullets that collecting this gun will give us. We are then getting the current held ammunition, updating the current magazine, which is the amount of bullets the player has left, adding the new bullets. If the magazine is already full, then we aren't going to do that. But we're basically then updating that. We're then going to set the new position of the sprite to the edge of the screen. This takes it off the screen, and that's its respawn point. And we're then going to get the sprite ready for the next time that it reappears. We're then going to jump here, and that will handle the reloading of the gun, because when you've selected the new gun, we want to reload it. Now, the only exception to that is if the player has hit a health power-up. If they have, we want to update the life. We want to take away the old life bar, add 8 units to the current life bar, and then we want to show the new life to the screen, and that's what we're doing there. So this is updating the player's life. We're making the collected some life sound, and then finally, again, we are just updating the power-up object, and we're just putting it off the screen so that it will respawn later on at a later date. Anyway, that's what we're going to be covering today. We're going to be looking at some more stuff next time. As I said before, this game is free. You can download the source code, and you can download the pre-built copies of the game if you can't be bothered to build it yourself. It's available for CPC, Spectrum Next, Sega Master System, Sam Coupe, and MSX2, basically the Amstrad CPC and the 16-color systems, because that's what you need. You need 4 bright colors minimum to do the 3D effect. You need a variety of colors. You need the primary colors, and you need some good resolution. So the sort of Sam Coupe is the sort of top functioning system. The CPC does a nice job as well, I think, as well, and I'm a big fan of the CPC, which is why I have covered that system. Anyway, if you like what you've seen today and if you want to support my content, you can buy a SuckHunt t-shirt, which is what I'm wearing here. You can get that from Teespring. Also, I need to tell you, I've now written a book. It's going to look like this. It's when I'm recording this, it's in the last stages of proofreading, but by the time you see this, it will be out on Amazon. Amazon, unless something crazy's happened. The book costs about £19 as a print copy, or about £9 as a digital copy, so you can get whichever you prefer. It's designed for absolute beginners. It covers the Z80, 6502, 68000, 8086 and ARM. The first chapter is an introduction to the kind of terminology and concepts you will come across in retro programming of all of those CPUs. And then there is a chapter on each CPU. It describes the basics of the CPU, things like the registers, the addressing modes, quirks and things like interrupt mode 2 on the Z80, for example, the things you might need to know about the CPU. And then there's some examples on each CPU for one of the easiest systems to cover on that, for example the CPC on the Z80. There is 3 samples, basically the simple sample series that I did in the past on this channel. That's included in the book, so how to create a sprite, how to show hello world, how to move a sprite around the screen. And then we go into a full instruction set on the CPU describing all of the commands in what I hope are reasonably easy to understand terminology. Basically, I went through all of the original documentation from the manufacturers of the processors for all of the commands, and I reinterpreted what they'd said in a way that I thought was as easy as possible to explain to someone who wasn't a CPU genius like those crazy people who write those kind of manuals are, because I find them overcomplicated, and I'm sure you do too. So if that sounds interesting to you, please take a look. There'll be a link in the bottom for you to see that on Amazon, and if you buy it, that would really help me out, and it would certainly encourage me to make more books in the future. So you know, if that's interesting to you, take a look. Anyway, I hope you've enjoyed this video. Thanks for watching today.